Hello. Hello. Hello.
We can we can hear you.
Yeah. So my name is Arun P. Madhu. I'm a member of e-Yantra, and today we will be diving a little bit into introduction to quadcopters. So everyone ready? Okay. So before diving into introduction of quadcopters, let us simply have a look at our flagship initiative of e-Yantra, e-Yantra robotics competition, and then we'll go into the today's session. So most of you might have heard about EYRC or e-Yantra robotics competition. So it's a 7 or 8 month long competition which we conduct. It has two stages, stage one and stage two. In stage one, students or people who register, mostly students, it's available to students who are doing their BTech or people, I mean, students in polytechnic colleges, and all kinds of students can participate. So the entire competition is divided into two stages. Stage one is simulation part. So whatever the main goal of the competition, you will first do it in simulation, and people who perform very well in the simulation will be selected for stage two, where we will ship you hardware and free of cost, and then you will be able to work on hardware and do the same thing that you did in simulation on hardware. So we'll be having different themes: drone theme, control system theme, one industrial robot and arm theme. Again, this year we'll have a line following theme, FPGA based theme, stuff like that. So registration, yeah, stage one, all of that. This is just a video of.
Huh?
So that was a overall video of the different themes we have in the previous years. And according to your participation in different stages, I mean stage one and stage two, you'll be awarded different level of certificate. Then we have around 10 lakh worth of cash prizes, e-Yantra goodies like t-shirt, swags and all. And the main thing is, so if you come into the finals of this e-Yantra robotics competition, or if you show yourself to be competent enough, you will be interviewed for a 8 weeks paid internship here at e-Yantra in IIT Bombay, where you will be able to work on cutting edge technology. So that is the most sweetest thing you get at the end of UARC. And for more details, you can visit this website portal.e-yantra.org, where you will be able to get more details about previous year's theme and uh, like get an overall idea of what this year's theme and all other details about e-Yantra robotics competition. You can get at this site. So that's all about EYRC. Now we will quickly move on to our session, Intro to Quadcopters. Give me 1 minute. Okay, let's begin. So today's agenda will be I will be introducing you to aerial robotics in general. Then we will be focusing on quadcopters. So we'll focus on quadcopter dynamics. Then I'll quickly tell you what all the components you need to make a quadcopter on your own. Then discuss some of the basic control system of a quadcopter. Control system. This, if you guys are from electronics or electrical background, you might get it more easily. Then we'll discuss some high level planning that you can do with your some applications on the laptop and all. And at the end, we'll discuss some of the applications of the drones in general. Okay, I guess we can dive into it. So, first of all, introduction to aerial robots. So, when you hear the name drone, these are the things that will might come into your mind. These all things, like a aerial photography drone. This is a DJI drone, which you might have seen. Then something like this. Then this is the drone used in military, mostly US and all. And this is a type of drone also. So the word drone is applicable to all of these things. So let's go to what the term drone means. So drone means a pilotless aircraft directed by remote control. So this was the definition we coined in 1946. So any kind of aircraft which is unmanned or doesn't require a human being to pilot it, we can term it as a drone. So all these kinds of things, this doesn't need a human to sit inside it and pilot. You can pilot it automatically using a handheld remote or a console or some sort of things like that. So that's a definition of a drone in a very layman term. Then some of the different classifications of the drone we can see. So one is multi-rotors. This is the one, multi-rotors. Multi-rotors means you will have more than one motors. Then winged aircraft. So drones like this can be classified as winged aircraft. And hybrid. So hybrid means you have rotors like this as well as you have wings. So the advantage of these kinds of things is you can vertically lift off and then fly like a normal plane. These are used in places where there is no runway, but you still want to uh, save fuel, because these kinds of aircraft have higher fuel efficiency. And you can like go into detail if you are interested on your own, but this is a overall definition of different aerial robots, like classification: multi-rotors, winged, and hybrid. So we'll be mostly focusing on multi-rotors in this session. So let's see. Multi-rotor is nothing but a rotorcraft having more than two lift generating motors. That means if the drone has more than two motors generating lift, like assisting or helping it to fly, we classify it as a multi-rotor. Examples are quadcopters, hexacopters. So quadcopters will have four motors, hexacopters will have six motors, then octocopters will have eight motors, and then there are bicopters and tricopters. So we'll be focusing on quadcopters in our session today, but there are hexacopters. These are mostly used in agriculture, both hexa and octocopters, because they provide redundancy, that if even if one of the motors fail to work, you can still you still be able to stabilize the drone using all the other motors. Then we have bicopters. These are very less common, and you have tricopters. These also are very less common, but you can see. So the most common out of these is quadcopters with four motors. So that was all just a brief introduction to what a drone meant, what were the different classifications of aerial robots, then what are the different types of multicopters, multirotors. There we saw quadcopter, hexa, octa, and bi and tricopters, and here we'll be focusing on more on quadcopter. So quadcopter dynamics really. So quadcopter is nothing but, as you see, we have four motors. Four motors are usually placed in a square shape like this. This is a DJI drone. So it every time it's not like it should be placed in a square. It can be a rectangular shape as well. But the most common configuration is square for its simplicity in working. You can also have other configuration that depends on your like if you are doing a project and that requires that type of configuration, you can do that, but this is the common configuration for motors usually placed in a square shape. Then we come to different types of motions a quadcopter can do. So there are four different kinds of motions. One is accelerate, second one is roll, third one is pitch, and fourth one is yaw. So accelerate means just this drone, all the four motors will rotate, and if the drone moves up and down, that is we can term as accelerate. Or sometimes we can also term it as thrust. So you are just moving upwards or downwards. Then we have roll and pitch motion. Roll motion is the drone moving sideways, and the pitch motion is the drone moving back and forth, and the yaw motion we can consider it as moving on its own axis. So yaw is like we consider the z axis. So if we consider a coordinate system for the drone, we have a z axis here, y axis here, and x axis here. So if it rotates around the z axis, it is termed as a yaw. I will show a video demonstrating all these motions, so don't worry. Then we have roll. Roll is around y-axis. Because of roll, there will the drone or the quadcopter will move side to side, and pitch motion is along y-axis, and because of this, the quadcopter will move forward and backward. So something interesting here to notice is that rotation around x-axis actually causes a motion around y-axis. So roll is rotation around x-axis, but when you roll a quadcopter, the resulting motion is it moves side by side, which is a motion along y-axis. And when you do a pitch, which is a rotation around y-axis, you will get a motion in forward and backward, which will be a motion around x-axis. That is something interesting that you can find in this quadcopter dynamics. Again, this is an image from a course in Coursera, aerial robots. This I added here so you can see all the different kinds of forces, moments, and the rotations of a drone. So each of these motors will produce a force in the upward direction, which helps the drone to lift off from the ground. So let's consider it as F1, F2, F3, and F4. Then we have moments M1, M2, M3, and M4. That is nothing but the torque generated due to the rotation of the motors along with the propellers. And we have W1, W2, W3, W4, which are just angular velocities of these motors. So something that you can see here is the torque and the angular velocity are in like opposite direction to each other. So the angular velocity will be in the direction in which the propeller is rotating. So when the propeller rotates, there will be a resultant force which counteracts the rotation of this uh, motion of the propellers. That is this moments M1, M2, and M3 and M4 that is showing here. And again, we have a coordinate system. So we have two coordinate system when we come to talk about drones. One is a global system. Consider this as the coordinate system of a person who is watching the drone, and then this is a body frame of the drone. So these are all very like some advanced concepts. I just wanted to mention this so you, if somebody is interested, they can have an idea. And if you are interested to learn about all this, you can visit this robotics uh, aerial robotics course on Coursera and have more idea about it. So we discussed there are different motions like throttle up, throttle down. That is accelerating up and decelerating down. Then pitch motion, then roll motion, and yaw motion. So you might have wondered how a quadcopter can achieve all kinds of motion. Look, I just mentioned there are different motion, but how actually the motion is being executed, that we'll see here. So this green represents normal speed and red represents high speed. So you have to be careful when you are seeing. So if you want to move down, like we just normal speed, or like we just decrease the velocity. If we decrease the velocity of all the four motors, the drone will come down. If we increase the velocity of all the four motors, the drone will go up. Basic stuff. Then we come to pitch control. Pitch control, as I have said previously, it is for moving forward or backward. That is motion in x axis, and which is due to rotation in y axis. So, in order for a quadcopter to pitch forward, you just increase the velocity of the rear two motors. So this is the front of the quadcopter. You just increase the velocity of the motors on the back side. So then the quadcopter will be able to pitch forward. So if you want to pitch backward, like if you want to move backward, you just increase the velocity of these two motors on the front side. Then the drone will be able to move backward. Similarly, coming to roll was what the motion of the drone on y axis, which is due to the rotation on z axis, I mean x axis. So due to rotation on x axis, the drone will move on y axis. So side by side motion. So to move left, you will increase the velocity of these two right motors, and in order to move right, you will increase the velocity of these two left motors. That is how roll is achieved. And finally, yaw. In order to yaw, you always increase or decrease the velocity of the opposite motors. So diagonally opposite motors, these motors will be rotating in the same direction, these two motors. So if you want to rotate left, you increase the velocity of these two motors, and if you want to rotate right, you want to increase the velocity of these two motors. So have you noticed anything in all of this diagram and the previous diagram? Like, uh, have you wondered that the motors does not does not rotate in any random direction. It has to rotate in a set direction. It can't, one motor can't rotate in clockwise randomly and the other motor can't rotate in anti-clockwise direction randomly. So there is a set pattern of rotation for the motor, so the drone will be able to fly, which is always make sure in a quadcopter the diagonally opposite motors are rotating in the same direction. So this motor is rotating in anti-clockwise direction. This should all, the diagonally opposite one also should rotate in the anti-clockwise direction. Then the other thing is the other motors should then rotate in the clockwise direction. So diagonally opposite motors should rotate in same direction, and the other pair of motors should opposite in, I mean, rotate in the opposite direction. So these two rotate in anti-clockwise direction and these two rotate in clockwise direction. So why this is necessary? One thing is that the blade of the propellers will be adjusted in such a way that if it rotate like this only, the air will be pushed down. So due to the air being pushed down, that's how the drone is able to lift. So we can say like this: we have a quadcopter, four motors, all of them rotate. Because of the rotation in a specified direction, the air from above is pushed downward. When the air is pushed downward due to Newton's third law, there will be a opposite force acting on the drone, which will help it to move upward. So that's how the drone is able to achieve lift, something we call as lift, and be able to move up and down. So, yeah. So, one reason I was saying for this arrangement of like direction of rotation of motors is to generate lift. The next thing is, previously we mentioned some moments like torque and some angular velocity and things like that. So that torque, like moment, was a reaction to the motor rotation of the motor. So if these are not arranged like this, the overall moment, if all of these motors are rotating in the same direction, the overall moment of the drone will be in this direction, and that will cause it to just rotate, continuously spin in one direction. If all the motors are rotating in this direction, then it will continuously spin in this direction. So because of this configuration, that diagonally opposite motors rotate in same direction and the other pair rotates in different direction, the overall moment or the overall torque created by rotation of, like, overall reaction torque created by the rotation of motors are cancelled out, so that the drone is able to stay in a stable state. It won't just randomly spin out of control. So that's a basic reason why you have this kind of arrangement of I mean, direction of motor rotation. I hope that is clear for all of you. So this was one of the main things in this session, like how a quadcopter can fly, how the lift is generated, what direction the motor should rotate in, how we can achieve throttle control, pitch control, roll control, and yaw control. All the things that we explain for will be based on this only. So I will just show a YouTube video which nicely explains whatever I have said so far, so you can see it and get a.
In this video, we're going to be looking at flying a drone using a controller in mode 2, and that's the most popular setting. That means the throttle's on the left. Push up, all the motors spin quicker, and the drone goes up in altitude. Pull down, the opposite happens. The left stick on the controller is also responsible for yaw, and this is where we use motor torque to our advantage. So if we push the stick to the left, the A propellers spin faster, with the torque making the drone yaw left or anti-clockwise. Push the left stick to the right and the opposite happens. The B propellers speed up and the torque makes the drone yaw to the right or in a clockwise direction. Let's look at the right stick on the controller now. That controls a couple of things as well. First of all, pitch. Push that forward. The rear two propellers speed up. The drone tilts forward and moves forward. Pull back and the opposite happens. The front ones speed up and the drone moves backwards. Pushing the stick to the left or the right will cause the craft to what we call roll. Push left, the B and A propellers on the right hand side speed up and the drone heads left. If you go to the right, the A and B propellers on the left-hand side speed up and it heads to the right. I'm Shane from Dronology, and that's drone flight physics in under 2 minutes. Thanks for watching and fly safe. In this video, we're going to be looking at flying a drone using a control.
So that was a quick demonstration video of all of the things I have said so far: how to accelerate up and down, how to do a roll, how to do a pitch and yaw. So I hope you have understood from the video how a drone flies. Yeah. So now we'll move on to the next section: how to make a quadcopter. So in this section, I'll just be discussing all of the different components that we need to make a quadcopter, and I will direct you to some resources where you can go and find out how exactly you can, like, if you are interested and curious enough, and if you want to make a quadcopter, how you can do that. So let's dive into. So these are some of most of the components. These are the components that you need to make a quadcopter. First comes the frame or the body of the quadcopter, then propellers, motors, motor drivers needed for those motors, flight controller, which is something known as a brain, which controls everything. Then remote control or and receiver. So remote control is for us to control the drone. Then GNS receiver, this is GPS. Then we have battery, and finally we have the software of the firmware, which will which gives the soul to the quadcopter, let's say like that. Okay, initially we will come to the frame. So I'll show you different types of frames. So the first one is just a plastic frame for a quadcopter. This is a combination of plastic as well as carbon fiber, and this is pure carbon fiber frame. So the advantage here is, like, if you are choosing only plastic, if you fly at a high altitude and you crash, this might get broken easily. But this is cheap. But in the case of a fully carbon fiber frame, this is lightweight as well as very durable, so it can survive crashes and all. But one of the thing is this will be costly, and then we have a middle ground in between, like a composite of carbon fiber and plastic. So this suits most of the purpose, like it's durable as well as not that costly also. So these are three types of frame. If a beginner wants to make a quadcopter, you can choose between any three types of frame. Then we come to propellers. Propellers are the component which help us to help us to achieve lift. Rotation of these propellers attached to the motors help us to achieve lift. So let's see the different types of propellers. So we have two-bladed propellers, three-bladed propellers, and four-bladed propellers. So different the blade configuration on these propellers have is according to different applications. So the normal quadcopters you see only have two-blade configuration. Three-blade and four-blade configuration are mainly used for racing or when you need very high response. So if you need the quadcopter to move very fast and respond at a very high rate, you need three-blade or four-blade propellers. All other cases, you only need a two-blade propeller. And these are the different types of material. This is a plastic propeller. No, sorry. This is a carbon fiber propeller. This is a plastic propeller, and this is a wooden propeller. So you can use any of these, but the most durable is a carbon fiber propeller. And then you have plastic propeller also. Plastic also you being used mainly, but after if you crash it 2-3 times, the edges of the plastic propeller will get like there will be small cuts on the edges, and that will result in bad lift, and the drone might not behave as you want it to behave. So you can choose plastic propellers, but if you are going if you have then you money, you can go for a carbon fiber propeller. It will be more durable. So that's all about propellers. Then we come to the next component, which is motors. So there are two types of motors which we use in drone. One is brushed DC motors, which all of you might have seen in your day-to-day like daily life inside toys like toy cars and all. They use this brushed DC motors. And then these are two different brushed DC motors. Then there is something called brushless DC motors. This is something you don't see in everyday objects or in everyday toys or anything. This is something like this. This we use in mostly in drones. You can use this also in drones, but the advantage for the brushless DC motor is that brushed DC motors have a brush which connects to the commutator of this motor. The problem is over time that brush gets veered off, and after a long time, the drone will not give you. I mean, sorry, the motor won't give you the performance that it initially gave you, and the entire motor will veer down. That problem is not there in brushless DC motor. You can have the same performance in the beginning and towards the like in throughout its lifetime. This is just the inside part of this brushless DC motor. We have a stator, rotor, and if I go into all these steps, that again will take a different session. So guys who are interested, you can just Google brushless DC motors, and you can learn how this the inner workings of a brushless DC motor. So if someone is going for building a drone, I suggest you go for a brushless DC motor. If you are just want to fly, like if you are very low on budget, then you can go for a brush DC. But I say the best motor for a quadcopter is a brushless DC motor. So previously I discussed about previously I discussed about propellers. Now we have seen motors. So you can't randomly choose any propeller and any motor. So for a given, if you want to build a drone of a given weight, or a yeah, so if you want to build a drone for of a given weight, you can just there is a combination of a motor and propeller. So according to the weight of the drone, you have to choose this combination of motors and this combination of propellers. There are lots of things going on. If you are interested, if someone is interested in building, this is something you have to keep in mind. So for a particular motor or a particular propeller will give a certain amount of thrust and things like that. It will also depend on the battery also. So people who are interested can look for that also while you are building a drone. Then we come to motor drivers. We have brushed DC motor drivers. This you might have seen in your if electronics people are there, you might have seen in your lab. Then there are motor drivers for brushless DC motors, and these are called electronic speed controllers or ESCs. These also you might have seen in your lab or something like that. I won't go into too much details because we have a time limit also for this session. So interested people can just Google this stuff and get on with it. Then we come to the important part, which is flight controller, and which is the brain of the computer, let's say. So this is flight controller. These are different types of flight controller. Let me show everything. So this is the industry best, which is called Pixox 6C. When we have something called Cube. This is a all-in-one flight controller, and this is our daily Arduino board. So all these things can act as a flight controller. So the definition of a flight controller is something like this: a computer capable of running complex algorithms to control the aircraft. It's nothing but so all the motor. So the motor requires PWM signals. The motor driver requires PWM signals in order to make the motors rotate. Then you have to consider what the position of the drone, what is the orientation of the drone. All things you need to consider, you need to control. All those things will be controlled using a something called as flight controllers. and this position and orientation is calculated using something called as IMU, inertial measurement unit. This is something that we find in our phones, smartphones, tablets, things like that. So you can Google what is an IMU. Most of you already know. So the IMU is present in all these three boards. On Arduino, it's not present. You can attach an IMU if you are doing, building a drone on your own. So these are things you can buy on market, and which will act as the brain of your quadcopter. There's lots to go on this alone, but I'll give you a quick link, and you can go and visit that and get more idea. And when we come to remote controls, so basically this is the remote control used by drone enthusiasts who build their own drones. uh, so this is used to control the throttle and yaw. Then you can control pitch and roll using this sticks. There are many switches to control other functions. This is the remote controller, and this is the receiver that we attach on a drone. Then we have something like this. This is also a remote controller. This is a remote controller you basically seen with um, what to say, DJ drones. Then we have the third one, which is an app. This is also, you can say, if you buy a drone from market, it can be considered as a remote controller. Then we come to something called as Global Navigation Satellite System, or GNSS receiver. So these are some of the receivers. The first one is a GPS we use on drone. The second one is a smaller version, and third one is something called as RTK GPS, which will provide very high level of accuracy, centimeter level accuracy. This also gives us good precision, and this is something we use on very nano drones. Of course, you all know what a GPS is used for, so I won't go deep into that. Again, we come to battery. We have three types of batteries. One is a lithium polymer battery, then lithium ion and lithium hydrate batteries. Mostly we'll use lipo batteries because of their ability to give a large amount of current at a short amount of time. That type of thing we need, because suddenly if you want to accelerate the drone or increase the throttle, it need a certain burst of current, sudden discharge. So that only the lipo battery will be able to provide. So mostly in most of the drones we use lipo batteries. And finally we come to the software of the firmware of the flight controller. So I said the flight controller was the brain, and maybe you can consider software as the consciousness inside that brain. So this will tell the flight controller is basically the hardware. The software or the firmware will tell it to do certain tasks. So we have four open source software or firmwares. One is PX for autopilot, second one is Beta Flight, third one is Pilot, and fourth one is INAV. The most common and famously used out of these four are Beta Flight and Pilot. Beta Flight is normally used for FPV drones, first person view drones, for racing and all kinds of stuff. And the Pilot is used for first person as well as all other kinds of drones. If you want to have an agricultural drone, or if you want to just build a drone on your own, I suggest you use the software or firmware Pilot. This has the most open source contribution, and you will find so much help in forums and stuff across the internet. Yeah, that's all about softwares. So that's all about the different components you need to build a drone. I wish if we had more time we could have gone more deeper into it and explained everything detailedly, but we have a time limit, so I just introduced you to different parts of a drone. So if you are very curious enough and you want to build a drone on your own, you just can Google all these stuff, and now you have an idea of what all things you actually need to build a drone on your own. I hope this helped. Now you this is something a little bit not introductory, it's a little bit advanced, but still we can go through it. Here we will be discussing the basic control system for a quadcopter. So what do like how do quadcopters stabilize on their own? Like one thing is user controls a quadcopter. We give data from a remote, the remote controller I showed earlier. So data from a remote controller, we will send it to the quadcopter uh, through the receiver, which are given as position commands. So let's start from the basics. So we all know the quadcopter will have motors. So in order for the motors to work, we need to have what we discuss in how to make a quadcopter. We need motor drivers. So motors need first motor drivers. Then motor drivers need something called as RPM. So like, RPM determines like its rotations per minute. So we give the motor driver RPM via PWM signal, which helps the motor rotate at a particular RPM which we have set. So can the user directly give RPMs? So through the receiver, I mean remote controller, we can't give RPM directly. We can't say the motors. We can command the motors to rotate at a particular RPM, because we don't know what RPM the motors will go up, go down, or do roll or pitch, something like that. So the user can't give RPM directly. Then what the user can give? Then so we can have a controller for orientation, controlling the orientation. So this controller can give RPM feedback, I mean RPM signals to the motor driver. So in this case, the user is required to give the angles. So can the user give angles? That is the second question. So angles is like, if you want to pitch forward, backward, or roll left or right, you need to do it at an angle. You need to pitch at an angle, let's say 10 degrees pitch. Then the drone will be able to move forward. If you want to move left or right, you again pitch at 12 degrees or something like that. So can the user give angle commands directly? No. Then what do we need? So yeah, so before going to what the user can actually give, let's consider the user is able to give angle commands. Then how do we know that this, like let's say we set an angle, like this is imagining the user is able to give angle commands directly. So the user said, let's say user said 10-degree angle command. So this controller, orientation controller, gave an RPM to the driver, and the driver like because I mean that because of the RPM given to the driver, let's say the motor rotated at that particular RPM. So how will we make sure the motor is actually rotating at the RPM? And due to the rotation, the quadcopter is at an angle which the user specified. How do we do that? So let's consider the driver and motors as a quadcopter, like the system. Then we can have something called as sensors to measure the angle of the quadcopter. So I have mentioned in the flight controller side, we have something called as IMU, or inertial measurement unit, to measure the orientation and position of your quadcopter. Just like you measure the orientation, just like you have an IMU inside your smartphone. Similar to that, you can have an IMU on your flight controller also. So what this does is, so let's say we have given an angle, and let's say this controller gives a RPM and the motor rotates and the drone actually uh, like pitches forward at an angle. Then we can measure through the IMU whether the drone is actually at an angle, at the angle specified by the user or not. So this in broader terms is like a feedback controller. So your user is giving an angle, and with the help of sensor we are measuring whether the angle is correct or not. If the angle is not correct, the measured value, then the user will, let's suppose the user will again be able to give this much angle to again reach the desired set angle. So these are all like some high level stuff. I can randomly just explain it to you out of the blue, but this is an overall idea of system feedback control and all. So the terms I say, system control system, you can Google control system, then you can Google something called as feedback control. Open This is a closed loop system. You can Google something called a closed loop system, and then you can you can actually read on your own what all this means. Actually, there is an upcoming talk on control system, so there you will be actually more uh, taken into how this what is a control system and what is feedback and all stuff. So after maybe attending that, this will more, I mean, this will make more sense to you. Yeah. So moving forward, so the only thing the user can directly give is something called as position. So we can say, if you have a XYZ coordinate system, we can ask the drone, or like we can command the drone to go to a particular position. That is something the user can do. So we introduce something called as a position controller, which is able to calculate the corresponding angle needed to go to a the required position. Then the rest is just like we have defined before. So in the end, this is a entire control system. Maybe you can take a screenshot of this or something like that, and then Google different stuff and understand how the entire thing works. So just I've said this is a little bit advanced stuff for just an introduction, but I wanted to show if somebody who understands control system is there, this will be very useful for them. Yeah, now we will quickly go through high level planning and application. It will hardly take some 5 7 minutes, and later we will be moving on to the conclusion of the session. Give me 1 minute. Yeah, high level planning means, let's say your drone has GPS. Let's assume your drone has GPS, and you want to plan a mission or something. Like you have to go to this GPS locations, then come back to the home. So this is in a quick way. What high level planning means is, you you plan a mission for the quadcopter to start from a home position, go to one GPS location coordinate, then to another coordinate, then to third coordinate, fourth and fifth. Maybe going through this coordinates, the drone is commanded to do specific tasks. Maybe the drone is supposed to pick something from here, drop it here, again pick something from here, drop it here, something like that. Or you can consider some, if the drone is used for delivery service, this home can be considered as a factory. You pick 5 types of things. Let's say you are Amazon, you pick 5 types of packages and you are delivering it at different location. So this is very high level control. But what we can do is, this is a screenshot of something called as an application called as mission planner. You can Google and get it. So in mission planner, if you have a drone with GPS, you can using the GPS put different GPS locations, and you can make the drone fly autonomously from your home to these different location, and again come and land back at the drone. So this is something you can make the drone do autonomously. You don't have to control the drone to go from these points. You just have to give the GPS locations, and it will go and come back. So if you are interested in this, you can Google mission planner, and you can get into more idea about this. And yeah, this is called mission mode. Then this app, we can call it as a ground station controller, QG. Ground station, yeah, it's, you can call it as a ground station. Apart from mission planner, there is one more such ground station known as QGS, that also you can Google. And there are forums and documentation explaining how you can do this kind of planning very nicely if you Google the term. Okay, moving on. Then again, on autonomous mode, if you are into research and all, instead of using apps and all to plan your own algorithm. You can use different path planning algorithms. For known environments you can use path planning algorithms like A star, Digistra, or RRT. I hope some of you might be familiar with this. If you are if your drone is flying in an unknown environment, like you have no previous idea, or you don't have any map of the environment, you can use algorithms like bugs algorithm, VFH, or 3D VFH. I won't go detailing into this. You can search on your own and understand, but this is the basic overview of different planning algorithms you can use on the drones. Then we come to the last part of the drones, which we will see what are the different applications of the drones. First one is just I mentioned before, the delivery. Like in some countries, they use, actually this is a hexacopter for delivery application. So you are delivering a package from one location to another. Just I have mentioned before, you will be using GPS coordinate. You will plan the mission. You have to go from here to here and all kinds of stuff. And just as we have talked in the beginning of the slide, we are using a hexacopter because in case one of the motor fails, still the drone will be able to fly. So that's why they use hexacopters or maybe octacopters in delivery and all. Then we have agricultural drones, where you have a payload of whatever pesticide or something you are spraying, and you have this is hex or octocopter, and you can spray pesticide like this. This is also an application of drones. These are seen mostly in foreign countries, but all in India, it's actually being more and more common in the it will be more and more common in the upcoming years. I think some of you guys might have seen this somewhere in agricultural fields. Now one of the next application is mapping and photogrammetry. So you can use drones are fly over the land to map the layout of the land and create a map of the land and stuff like that. Then we use drones for surveillance also. So police or authorities might use drones for surveillance and stuff like that. Then we can use drones for transport also. This is something that have been happening, like some future stuff, but some of the countries have developed drones in which persons can fly also. Then lastly, aerial cinematography and photography. This is one of the most common things you might have seen, like DJ drones are famous for. And so this is just the I will skip through it because we have a time limit, and this is a something
Thumbs up from
racing of
Chance.
drones.
Thumbs up from Chance. Frank's going down the line, making sure everybody's video is good. He's a guy.
We'll just show a clip of this.
So a 20-minute race. That had a plan, and it looks like they're sticking to it and running fast laps right now. They've gotten down into the 21s and the 22s pretty consistently. So maybe save their fast pilot for the end.
So now we'll come to the question session. Sorry, I had to skip through it. We were like little bit crucial on time. So, do you have any questions so far? I will go to the chat. We have some questions. When will the okay? One question: when will the registration start for e-Yantra? So, you keep an eye on the portal, and mostly the registration will start in August, September time. So you can keep an eye on the portal, and we will open the registration on the portal itself. The portal I have explained initially. Where should I purchase all the parts to build a drone? So to purchase the parts for a drone, you can find parts on websites like robo.in something known as. Then There are websites called DRK Store, Quadcart, Bookmasters, uh, Anubis RC. There are different websites, so yeah, you can go and find there. Yeah, there are so many tools. What are the necessary qualities the drone should have so that it would be considered as a good project? So qualities like that depends on your project. So I have discussed about all the basic things you need to actually build a drone. The any additional sensors or things that you add on the drone depends on your personal preference or whatever thing you are trying to do. How to integrate nav to stacks with drone? So this hasn't been done so far. There are some open source libraries which have been trying to introduce nav2 stacks with drone. Maybe you can go into GitHub and search and you can find out like that. Why doesn't BLDC have 40,000 RPM? So drones we use for FPV, and so the question is why doesn't BLDCs have 40,000 RPM? The drones we use in FPV and all kind of have maximum around 21, 23,000 something like RPM. So higher RPMs it's not commonly found. I want to simulate this drone working in this. Yeah, you can simulate the drone in Gazebo. And in our EYRC competition, one of the stage one task is to fly a drone in Gazebo. So if you are interested, you can come and like participate in the competition and learn how to fly a drone in the Gazebo. Important 3D path planning algorithms. So the algorithms I have discussed you can use for 3D path planning. Your other algorithms, if you can do slam on rounds, then you can create a map and all. You can use all of the algorithm I have specified in the slides. Yeah, does a drone use PID algorithm? Yes, a drone uses a PID algorithm. So I have said the software of the firmware of the drone will contain inbuilt PID algorithms. So when you give commands from your transmitter or your remote control, those commands are actually going into a, let's say, into the firmware where different PID algorithms are working in order to balance the drone. Can you share any resource for drone software development using ROS 2? So the best way to get resources for drone software development using ROS 2 is to participate in the EYRC competition, especially in the drone team. There we will teach all these things. How can we make our own drone? So that's what I have discussed in the session. Can we 3D print propeller? So 3D printing can we 3D print propeller and frames, and how good it is? So you can 3D print propellers and frames. That the problem is when you exert like you can fly for maybe a minute or two afterwards, because of the forces exerted by the motors, like due to the lift and lift generated by the motors and all, the frame will bend or break after some time. So it's not recommended to use a 3D printed frame, or you can print it with a very like high infill or something, then you can use it. Okay, now we can go into some, I guess I don't have time to answer all the questions. We can go into quiz. So before going into quiz, I will. So this was today's talk was intro to quadcopters. So the next talk is scheduled for 26th July 2025, which is FPGA for beginners. Then there we will be they will be discussing about what is FPGA and how you can use it and all kinds of stuff like that. This is a registration link, so anyone who is in this talk is interested, you can register at this link. And after that, then intro to Bash will come. Okay, so now is the time for quiz. There will be only 5 minutes for the quiz. You have to use the same name and email ID you are used for registration in the WebEx. Okay, so before that, I thank all the people who have been watching us through YouTube. Thank you so much for attending, and I hope you all had a wonderful opportunity to get to know about quadcopters. Yeah, and I hope I have created a curiosity in your mind about quadcopters. Thank you. And for the WebEx, people who are in the WebEx, I will share the link for the quiz in the chat. You have 5 minutes. After that, the quiz will be closed.